it is better if we see these things in practice. But I'm afraid I think that I don't have the pie chart here, so we can just see the code but nothing else. So this is the code for linear programming optimization. The problem we saw, what was our problem? The problem was we have X and X2 unit labors, and the constraint says we can't have more than 20 labors, and another constraint is we have to produce more than 90 units of products in a day. একদিনে আমাদের 90টার চেয়ে বেশি প্রোডাক্ট তৈরি করতে হবে, 20টার বেশি লেবার নেওয়া যাবে না, এবং আমাদের X1 X2 দুটো মেশিন আছে. Now the question is, how can we optimize the situation? কিভাবে আমরা এমন কিছু করতে পারি যেখানে আমার ইন্ডাস্ট্রিটা অপটিমাম ওয়েতে চলবে? So that's the findings of linear programming. And if you run this code, I'll share this code right after the class. If you run this code in a PyCharm, the PyCharm, this logic of this code will automatically optimize the situation for you, and it will give us the result that কোন মেশিনটা কতক্ষণ চলতে হবে, that means X1 কতক্ষণ চলতে হবে, X2 কতক্ষণ চলতে হবে, কোন মেশিনে আমরা কতটুকু লেবার দেব. Everything will be calculated by this code. And how it works, it is a very powerful technique, but the mechanism is pretty simple. এটা কাজ করে হচ্ছে simple a linear equation গুলোর মাধ্যমে. It's very powerful, very handy. We use it frequently. However, at the back end, under the hood, if you see, it's pretty simple linear equation. That's it. So there is a proverb saying that all the good things are simple. It's like that. At the back end, it's pretty simple. And the algorithm we use is simplex and interior point. Those are already implemented in Skippy library. So we just call that algorithm. That's it. We don't need to understand how this algorithm is working. But what we do need to understand is constraint satisfaction. So there is one way we can satisfy the constraints, that is linear programming. And let's understand what is this constraint satisfaction a little deeper. So have you ever faced the problem that you have 2 exams on the same time on the same day? এরকম প্রবলেম কারো হয়েছে? একই দিনে একই সাথে দুটো পরীক্ষা?
জি স্যার, এরকম স্যার অনেকেরই হয়.
Yeah, it happens frequently. It happens because of the lack of optimization. So as you are already familiar with this kind of scenario, this kind of situation, so we will create such type of problem. Then we will use this constraint satisfaction problem solution technique to optimize the situation. So what do we have? We have the student 1, 2, 3, and 4. We have 4 students, and the classes they are taking. Class taking means, in English, taking means attending the class. Like you are taking this course, I'm conducting this course. English class taking করা মানে বোঝায় বাংলা হচ্ছে ক্লাস করা, এটা ক্লাস নেয়া না. So they are taking the courses. Student 1 is taking A, B, and C. Student 2 is enrolled in B, D, and E. Student 3 is C, E, F, and student 4 is in E, F, G. These are their classes. Now the exam slots. They have only 3 exam slots: Monday, Tuesday, and Wednesday. So what can we do to make sure that no student have 2 exams on the same day? So what is the constraints? Constraints are no student can have 2 exams on the same day. একই দিনে দুটো এক্সাম থাকতে পারবে না. That's the constraints. So this is our human idea, human concept. How can we convert this human concept into computing, into the concept of computer? We can do that using graph theory. So this is the application of graph theory. I'm pretty sure that you have all studied graph theory in CSE 307. So we are going to recall those. If you can't recall, don't be worried at all. I'm going to explain everything. So these nodes, A, B, C, D, E, F, G, these nodes are actually our classes. This from A to G classes has been represented with the nodes. And we represent the constraints with an edge. So these are constraints. These edges are constraints. I think you remember that in discrete mathematics, we learned what is an edge. An edge is the connecting point between two vertices or two nodes. So what these nodes, what these edges are actually representing here, this edge represents that A and B cannot have exam on same day. Now, you can be confused here with one thing. অনেকেই একটা জিনিস মনে করতে পারো যেটা হয় প্রায় হয় যে এই দাগটা দেখে অনেকে মনে করে যে A B একই দিনে হবে. It's actually not like that. It means that A and B can't have an exam on the same day. That means course A and course B can't have exam on the same day. এই যে একদিনে পরীক্ষা থাকতে পারবে না, এই সম্পর্কটাই আমরা এজ দিয়ে বুঝিয়েছি। মানে এই দাগ মানে হচ্ছে একদিনে পরীক্ষা থাকতে পারবে না। At the same time, B and C can't have exam on the same day. At the same time, A and C can't have exam on the same day. So this is how, using graph theory, we can formalize our problem in the way we can encode in the computer. So what we can see here, for second student, B and D, D and E can't have the exam on the same day. For the third student, C and F and E can't have exam on the same day. For the fourth student, the course F and E and G can't have exam on the same day. So this is the constraints. Now, this is our data structure. Now we will work on this data structure using several algorithms. So what are those algorithms and what should we deal with it? This is the answer. So let's start here. So constraint satisfaction problem, or in short, CSE. This is the short form of constraint satisfaction problem. Please ignore my handwriting as I'm writing with a mouse. You know, I don't have any graphics map today, so it's really awkward. But yet, try to understand. This is C. Okay, let me rewrite it. CSE. This is the short form of constraint satisfaction problem. So what do we have in constraint satisfaction problem? First things first, we have a set of variables. Then we have a set of domain for each variable. Then we have the constraints. So we have three parameters to deal with constraint satisfaction problem. So I don't want to explain what is in pseudocode. It makes things complicated. But let's understand our example, what problem we face. যে প্রবলেমগুলো আমরা পরীক্ষার সময় ফেস করি, যে একদিনে দুটো পরীক্ষা পড়ে গেছে। So what are the variables here? We know that in CSP we have variable, domain, and constraints. So what are our variables? The courses are variables. What are the domain? The exam schedule is the domain. And what are the constraints? The constraints are A cannot be equals B. Now there's a quick question to the class. How did we express this particular relation? A is not equals to B. How did we express this relation?
Sir, একই দিনে A এবং B exam হবে না, এটা স্যার বুঝাচ্ছে।
Yes, that is a valid answer. কিন্তু এই data structure এর মধ্যে, in this data structure, how did we represent this relation?
Sir, একটা sign আছে।
Okay, using edge. Now we are becoming more mathematical. This edge means it cannot be
same time.
cannot be same এখানে equal দিয়ে কিন্তু আমরা অ্যাসাইনমেন্ট অপারেটর বোঝাচ্ছি না এখানে equal দিয়ে আমরা equal বোঝাচ্ছি that means the same equal so A cannot be on the same day as B. The next constraint, A cannot be on the same day of C with C. B cannot be on the same day with C. So these are our constraints. Now let's see how can we satisfy these constraints. So before we started studying how to satisfy the constraints, we should know that there are two types of constraints. Hard constraints means there is no option but to maintain that. It has to be satisfied. And soft constraints means maybe there are some options to exclude that. So just remember it from this perspective. Hard means we have to do it. Soft means there could be some options to exclude it. But for the time being, we're dealing with hard constraints. So let's start studying these different types of constraints. So when we have only one constraint that A cannot be equals non-day, it's called an unary constraint. Unary came from the uni. Uni means one. From there we have derived this word unary. Unary means there will be only one constraint. And opposite to the unary is binary. What is binary? We will have two constraints. That means A cannot be equals to B, B cannot be equals A. We have two variables here. A and B are two variables. That's why it is binary constraints. If we have only one variable, that is A, then it is a unary constraint. So when a constraint is unary, when we have only one variable, when a constraint is binary, when we have two variables. And when a node is consistent, when all the constraints are valid, যখন সবগুলো constraints valid হয়, at that time we call it is a node consistency. Now I'm not explaining these concepts in details because we have a nice pictorial representation for it. Everything becomes clear from this pictorial representation and it is somewhat animated, so it helps us to understand better. I want to draw your attention here. How many variables do we have here in this circle?
One variable.
একটা স্যার
One. So is this unary constraints or
Yes,
binary
sir.
constraints?
Is this unary constraint?
ইউনারি স্যার
Okay, excellent. This is a unary constraints. Okay, now tell me how many variables we have here.
Two variables.
দুইটা স্যার
Is it unary or binary constraints?
Binary.
This is binary constraint.
Binary constraints. Very good. Now let's talk about first unary constraints. In the first unary constraints, it says that A cannot be equals Monday. But we can see in A, we have Monday. So is this node consistent? No, this node is not consistent. A node will be consistent. Let me write it. Consistent. It's pretty difficult to write with the mouse. Let us go back to, this is node consistency. When all the variables, all the values in a variable's domain satisfy the variable's unary constraints, only then the node is consistent. Now, we can see here that first unary constraints is not satisfied here. So is this a consistent node?
No, sir.
No, it's not a consistent node. Now, let me point out one thing. Suppose this type of question is given in your final exam, and the question says that, are these nodes consistent? Or say that there is not 2, but 5 nodes are here. The question says that, are these nodes consistent? Can you figure it out if it is consistent or not? If the condition is given. যদি কন্ডিশন দেয়া থাকে তাহলে কি নোড কনসিস্টেন্সি বের করা যাবে? I think we're having a technical problem. Can you hear me properly?
Sir, আর একবার একটু বলবেন স্যার, বুঝতে পারিনি।
Okay, no problem.
Clearly.
As if necessary. Okay. Please pay your attention here. When all values in a variable's domain satisfies the variable's unary constraints. তার মানে হচ্ছে যখন একটা ভ্যারিয়েবলের unary constraints গুলো satisfied হয় তখন সেই নোডটা হয় consistent. একটা নোড তখন consistent হবে যখন unary constraint গুলো satisfied হবে. So we know what is unary constraints. Unary constraints means where there is only one variable, that is called unary constraint. আমাদের প্রথম unary constraints হচ্ছে a cannot be equals Monday, and in the node we can see that a also includes Monday. So the question is a consistent?
No, sir.
No, sir.
No, sir.
No, it is not consistent. So এইভাবে এরকম দুটো নোডের পরিবর্তে যদি অনেকগুলো নোড দেয়া থাকে and if these constraints are given তাহলে কনস্ট্রেন্ট বের করতে পারবে না কোনটা কনসিস্টেন্ট এবং কোনটা কনসিস্টেন্ট না?
হ্যাঁ স্যার, বের করতে পারবো ইনশাআল্লাহ।
Okay, very good. It's a pretty simple problem actually. So in this case, what action can we take? We can do one thing. We can remove Monday from A. So first unary constraints now is satisfied. Then the second unary constraints, B cannot be equals Tuesday. So remove Tuesday. Third unary constraints, B cannot be equals Monday. Okay, remove it. Now next we are left with the binary constraints. A cannot be equals B. However, we can see that for the first variable, it's okay. A is not equals B. But for the second one, A is equals B. That means binary condition is not satisfied. So how do we define this situation? We define this situation as arc consistency. So we have two types of consistency: node consistency and arc consistency. So what is arc consistency? Don't think it in a complicated way. Let us think it in a very simple way. In order to do that, someone please tell me what is an arc? Arc bolte ki bocho? Okay, not a big deal. Let us see what is an arc. What is an arc? If you go to the image, arc is nothing but connection between 2 points. If you see the definition, in general, an arc is a smooth curve joining 2 points. মানে arc হচ্ছে একটা curve যেটাকে যা দুটো পয়েন্টকে সংযুক্ত করছে. As simple as that. Now here, this line is connecting 2 points, A and B. That means this line is the arc. So এতটুকু বোঝা গেছে what is an arc?
Yes sir. A আর B দুটো পয়েন্ট
Okay.
মানে কানেক্ট করছে।
Yes, this connecting point is arc. যখন আমরা বুঝে গেছি what is arc, now it's a piece of cake to understand arc consistency.
Yes sir.
In a variable, when we talked about node consistency, we had only one variable. এর জন্য একটা condition hold করলেই it was fine. But now we are not talking about node consistency, we're talking about arc consistency. How many points an arc has? An arc has 2 endpoints. একটা arc-এর দুটো endpoint আছে। তার মানে দুটো endpoint-এই constraints fulfill হতে হবে. So what is the constraints? A cannot be equals B. So in that case, if we simply remove the Wednesday from here, now is the arc is consistent?
Yes, sir. I think it's
I
completely.
think it is consistent. Sir.
These constraints, A is not equals
B.
B. Or A is not equals B, A সম্পর্কটা দেখানো হয়েছে এই এজ এর মাধ্যমে, যে এজটার নাম হচ্ছে
arc.
arc. So as simple as that. Now we will understand this concept in the simplest possible way. Slide কি আছে, let's forget about that. সবকিছু ভুলে যে let's talk like a discussion. So we are talking about constraint satisfaction problem. So এমন এক ধরনের সমস্যা যেখানে কিছু constraints দেয়া থাকে, আমাদের সেগুলোকে সলভ করতে হয়. So for that we have two types of constraints. We have two types of consistency, arc consistency and node consistency. Node মানে তো একটা জিনিস, তার মানে এখানে একটাই ভ্যারিয়েবল হবে। সেই একটা ভ্যারিয়েবল যদি কোনো একটা কনস্ট্রেন্ট দেয়া থাকে, সেটা স্যাটিসফাইড হলেই we will say that it is node consistent. So এখানে একটা জিনিসই থাকবে। But in an arc, একটা আর্কের মধ্যে দুটো পয়েন্ট থাকে, স্টার্টিং পয়েন্ট এন্ড এন্ডিং পয়েন্ট। তাহলে এই আর্কটা কখন কনসিস্টেন্ট হবে? যখন দুটো পয়েন্টই স্যাটিসফাইড হবে। দুটো পয়েন্ট মানে হচ্ছে দুটো ভ্যারিয়েবল। সো দুটো ভ্যারিয়েবল যদি থাকে, দ্যাট ইজ বাইনারি। তার মানে যখন বাইনারি কনস্ট্রেন্ট স্যাটিসফাইড হবে, দেন উই উইল কল ইট an arc consistency. So when unary constraint is satisfied, it is node consistency. When binary constraint is satisfied, it is called arc consistency. Is it clear?
Yes, sir.
Okay, very good. Now, as the consistency is clear, so now we can jump into the algorithm of arc consistency. But it is little complicated to understand from here, but it is very easy to understand from the animated graph for once again. So let's understand this algorithm, arc consistency algorithm, from here. So these are our variables. A, B, C, D up to G are the variables. And these are the domains. Monday, Tuesday, Wednesday, these are the domains. A quick question to the class. If A, B, C, D, these are variables, these are domains, where are our constraints? This
Sir,
A,
ages.
Sir, age.
variable, this A, B, C, D are variable. These are domain. So where are our constraints?
Sir, ages গুলা।
The edges. Okay, excellent. These edges are our constraints. Okay, now as we know everything, let's see that what can be done here. Now, okay, these things are not necessary. I'm going to solve it directly here. So the constraint says that we cannot have two exams on the same day. And what are our days? Monday, Tuesday, and Wednesday.
স্যার কি প্রথমে অ্যাটেন্ডেন্স নিয়ে নিছে?
চ্যাট বক্সে নিতেছে।
ও আচ্ছা।
I have only 73 kbps connection. I don't know how it is working. Okay, let us get back to where we was. Now this arc is consistent. So let's take care of the other term. From here, let's pick up Monday for the D. Okay, it looks like it's fine. Now, for E, can we pick Monday?
No, sir.
Okay, then this arc is become inconsistent. So we cannot take E as on Monday. So can you take E on Tuesday?
Yes, sir.
Yes, sir.
Yes, sir.
Are you sure?
Yes, sir. কারণ D এবং E স্যার এখানে
না
স্যার B আর E অবশ্য কানেক্টেড আছে।
না B আর E আছে।
তাহলে
জি স্যার, বি আর ই কানেক্ট আছে স্যার।
এটা হবে না।
Now B and E, we know that this
এটা not consistent.
edge means B and E cannot have the same exam on the same day. So again, there is a problem. So this is the problem. What can we do? Let's take it on Wednesday.
Yes, sir.
So now, consistent?
Yes, sir.
Okay, looks like consistent. Okay, now Look at this C. Can we take Monday?
No, sir.
No, sir.
Okay. Problem. Tuesday, problem. Wednesday, problem. Now what can we do? We have only 3 slots. So what can be done here? Any idea, any suggestion? Okay. So
within
this constraint is not being satisfied. So what can we do? We can do backtracking. So what is backtracking? We will go back. So this is where we were. We will go back. And we will keep tracking at the back and trying to figure out which solution is going to work. So I skipped one slide, you have noticed. That was, I'm going there again. Okay. Now, as we have understood what is backtracking, now it is a good time for us to go back to backtracking search. This type of search is called backtracking search. So what it does, it keeps optimizing the schedule or whatever the problem is, whatever the solution is. But once it figures out that there is no solution, then it starts backtracking. It starts backtracking and then reorganize things and find out the solution, or reorganize things in such a way so that it can find a solution. This type of algorithm is called backtracking search. So now we are moving forward from A to B, then from B to D, from D to E. Up to this point, it looked like that everything is fine, but this is where we got stuck. We got stuck here. We have no other option, nothing else to do. So now we are going to apply the backtracking algorithm. What backtrack will do, it will go back. It will go back. Going back means, no, I'm not taking Monday here. I'm bringing back the previous domain. Then I'm not picking up anything. I'm reversing what I have already done. Then again reversing. Then again. Now instead of, like we have Tuesday here, instead of Tuesday, I'm picking up Wednesday here. Then picking up Monday here. Then we can see that again there is a violation of the rules. If we use Tuesday, again there is a violation of the rules. But this time if we use Wednesday here, the arc consistency is satisfied. So using backtracking, we change one variable to one value, and now the arc is consistent. Let's start moving forward. Now we can take Monday here, but if we take Monday, it is not satisfying. So instead of Monday, let's pick Tuesday. And instead of Monday here, let's pick Tuesday. Again, the violation, now Wednesday. So this is how we can optimize this student's problem. So we have 4 students. We have 3, each of the students are taking 3 courses. We have 3 slots. And this data structure is showing us that if we organize it in this way, no student will have back-to-back exam on the same day. So this is an example of constraint satisfaction problem, and we apply the backtracking algorithm here to solve it. Now, how to implement this one? As I knew last night that I have to come to office today, so it is almost impossible to contact the lab from here. So I have already coded everything for you. If you run this code, it will automatically solve the problem. Okay, so we have solved one problem using backtracking algorithm, but it has a limitation. The limitation is it takes some time for us. It takes some time for the algorithm to understand, to figure out that there is a problem. So it goes back, solve that problem, and then again progress forward. Luckily, we had only one problem here, so it didn't take that longer to figure out the. It didn't take that longer for us to figure out the problem. Now think about 10,000 students taking 30,000 courses, and there are exams on 7 days. Now the problem will be very, very complicated, and backtracking algorithm will start working, will start taking considerable amount of long time to give us the optimum result. So how can we solve it? We can solve it by inference. This is what we have already covered. Inference means a set of information is given to us. We will infer based on that those information. In other words, we will perceive the environment. From that environment, we will infer no information. So existing knowledge ke combine kore notun knowledge toiri kora. That is what inference is. We can apply the concept of inference to make this backtracking algorithm faster. So how can it be done? So Monday and Tuesday, it has been assigned. Now we can infer. If we assign Monday here, what will happen? If we assign Monday here, then there will be a problem because Monday, Tuesday. Here is Monday, Tuesday. So if we assign Wednesday here, only Wednesday is remaining for C as well. That means E and C will have clash. So it can be inferred beforehand. How is that? So how we infer? Let me write. We have knowledge K1. We have knowledge K2. Based on this existing knowledge, we infer new knowledge, K3. আমরা এই ধরনের একটা ল্যাবও করেছিলাম, and in that lab we inferred who is the murderer. মনে আছে সবার যে আমরা একটা ল্যাব করেছিলাম কে খুন করেছে?
Game of clue.
জি স্যার।
We were given few clues. From there, we derived other clues, and we were correct. So here we are using the same concept, same algorithm, everything is same, but instead of murderer, খুনির পরিবর্তে এখন আমরা যে তথ্যগুলো নিচ্ছি, those are these two information. এই দুটো information, and along with that, the relation among these nodes. এই নোডের মধ্যে যে রিলেশন গুলো আছে, এই তথ্যগুলো আমরা নিয়ে we are inferring new knowledge, যে backtrack করার আগে আমরা বুঝে যাব যে কি হতে পারে. So how is that? Monday, Tuesday are given. These arcs are also given. These arcs are also given. That means these are the constraints are also given. কোনো কিছু দেয়া মানেই হচ্ছে আমাদের knowledge base already knowledge আছে, সেটা ব্যবহার করে we will generate new knowledge. Now from here, if we pick Monday, what is going to happen? এটা আমাদের knowledge base থেকে আমরা knowledge নিয়ে we will see that there is a relation here, there is a relation here. Monday, Tuesday has been used. That means because of these two relation, only Wednesday is remaining. So we inferred it that C এর জন্য শুধুমাত্র Wednesday বাকি আছে. কিভাবে infer করলাম? Monday, Tuesday, and these two constraints. So one inference. Then, if we use Monday here, Tuesday has been used here, so we can infer that Wednesday is the only option remaining here. Okay, we inferred that. If we use Monday here, we have to use Wednesday here. So আমরা আরেকটা জিনিস infer করে নিলাম. So এখন নতুন যে ইনফারেন্স তৈরি হলো, মানে আগের ইনফরমেশন থেকে নতুন নলেজ তৈরি করলাম, সেই নতুন নলেজ থেকে আবার নতুন নলেজ তৈরি করব. In that case, we can see that the arc consistency becomes invalid. That means we can't do that. So backtracking করার আগে আমরা ইনফারেন্সের মাধ্যমে আগেই জেনে গেলাম যে there will be a problem. So what can we do? We can't take Monday. So what can be taken? Let's pick Wednesday here. let's take Monday here and take Wednesday here. Then there is no problem. So this is how we can apply inference. And if you apply inference, the system becomes a lot more faster, because before taking action, we know what is going to be the right action. And in backtracking, we keep taking action. Then at a certain point, we understand that something went wrong. Then we start backtracking. Now think about it that for 100 students, 400 courses and 7 days, একেবারে শেষ নোডে এসে যে ব্যাকট্র্যাকিং অ্যালগরিদম বুঝলো যে একটা প্রবলেম হয়েছে, তাহলে তাকে শত শত নোড আবার ভিজিট করতে হবে। But if the inference rules is used, then before there would be a problem, our algorithm is intelligent enough, it will understand. But in this case, the computation is little more complicated, little more complex. It will take more computational power. এর জন্য আমাদের আরো বেশি computational power দরকার, but it is faster. So that's how using
যেহেতু স্যার আমরা ব্যাকট্র্যাকিং করার আগে স্যার ইনফারেন্সের মাধ্যমে জেনে যাচ্ছে স্যার, সেক্ষেত্রে তো এটা ফাস্ট অবশ্যই হবে স্যার। আর যখন এখানে অনেক হাজার হাজার নোট থাকবে, কোটি কোটি নোট থাকবে, রিলেশন থাকবে, সেই ক্ষেত্রে দেখা যাচ্ছে যে আমার ব্যাকট্র্যাকিং করতে অনেক টাইম লাগবে। টাইমের আসলে শেষ নেই বলা যায়।
Yes, it will take lots of time. Okay, now I want to ask a question, but don't be sad or disappointed if you can't remember it. What is the degree of this node? মনে না থাকলে মন খারাপ করার কিছু নেই। This is we are human being, আমরা ভুলে যাই, so it's fine. এই নোডটার ডিগ্রি কি হতে পারে?
স্যার দুইটা এজ আছে স্যার।
দুইটা এজ আছে, সেটা তার ডিগ্রি। মানে যে কটা এজ আছে কানেক্টেড।
The degree is 2. Okay, degree is 2. Very good. What is the degree of this node?
5 sir. First degree.
5 sir.
আচ্ছা, যাদের মনে নেই, মন খারাপ করার কিছু নেই, আমরা ডিগ্রি গুলো কাউন্ট করি হচ্ছে কয়টা এজ কানেক্টেড আছে তার উপর ভিত্তি করে। সো এখানে আমাদের 1 2 3 4 and 5 আমাদের 5টা এজ কানেক্টেড আছে। That means the degree is 5. Okay. Now, when we want to apply inference rules, এই নোট থেকে যদি আমরা ইনফারেন্স রুল অ্যাপ্লাই করতে চাই, তাহলে তাকে এই 5টা